How do you develop aerobically? That's the question we're going to answer today, and we're going to nerd out on both the science and also the training to do so. So first I want to start with the science, and we're going to go into the weeds a little bit, but I promise I'm going to try and simplify it as best I can and give you actionable takeaways from it. And the reason we're going into the weeds is I think it's important to understand the complexity of this. So often when we get told to train aerobically, we either think, okay, I need to do a lot of high volume, easy work, zone 2, or I'm going to shortcut that and do some quote unquote high intensity training to get those adaptations in a more efficient time period. Okay, the truth is, any relatively aerobic training will help your aerobic development. But what you're going to learn today is you need a variety of intensities and volumes to actually do the job, because it's more complex than we kind of show it out there. So let's get into some of the science. So let's simplify first. How do we get an adaptation? What happens is we apply some sort of stressor. You go run, and guess what? There's different stressors depending on the intensity. You can have mechanical stressors, meaning the stretching and contracting of the muscle fibers themselves as a stressor that the body responds to. We have substrate stressors, things like how much carbohydrate and fat are you utilizing, or whatever have you. Are you diving into your glycogen stores till you're potentially running out? We have oxidative stress, so more reactive oxygen species come up to kind of do some damage, and we have to repair that, and all sorts of other things. We have all of these different stressors. We have other metabolic stressors. When we look at things like our ADP to ATP ratio, we're going to use a lot of acronyms. That basically means, where is your energy balance in there in terms of in your muscle itself. We can look at the accumulation of byproducts or different substances in there. Traditionally, we think of lactate or lactic acid. That's not really a bad thing, but it comes along with hydrogen ions and other things that kind of signal, hey, we got to adapt here in a specific direction. Now, here's where, again, I promise, we're going to sort it all out. Often in the exercise science world, you hear of adaptations, you say, oh, we've got to get more mitochondria. You go online and you say, okay, you've got to activate this pathway, and you do this, and you do this workout to activate this pathway, and you get this adaptation. The reality is there are a bunch of different pathways. Meaning from CMK to MAPK to AMPK to PKA to ERK to all sorts of acronyms that don't really matter. But the point is, when I was way back in grad school, I remember my professor telling me this. He said, look, pathways are great. They help us understand things. But the reality is, 10 years from now, you're going to have another half dozen pathways where you're going to be like, oh crap, things aren't as easy. And then 10 years from that, another half dozen pathways where you're like, oh, this is more of a mess. And guess what? He told me that in, 2010. It's true. Things look simple. If you go read my Science of Running book, which is great, it's wonderful, but I wrote it in 2013, I think, is you'll see I pit high intensity and endurance training as this battle between these two pathways, because that's where the science was at the time. But instead of seeing this battle between contrasting pathways, what we now see is almost like this network effect. And I'm going to put a graphic up here somewhere that shows the overlapping, in this case, the proteins, but the proteins at the end of the signaling pathway is the end result, what happens. But you can see the overlap between endurance training, high intensity endurance training, and sprint interval training. So across the intensity spectrum. And what is, you see, oh, there's a bunch of proteins that get activated, whatever word you want to use, just from endurance. But there's also this Venn diagram effect that occurs. Because what we know now is that instead of seeing things as activating this pathway and we're good, it's more of this network effect that goes both ways. What do I mean by this? Again, sorry for getting in the weeds, but when we look at the things that happen in the mitochondria, and the nucleus of the cell. Go back to high school biology. Nucleus, sitting here in the main part. Mitochondria, the powerhouse. We used to think it's a one-way talk between those. No. Now we know it's a two-way street of communication to get to some sort of adaptation. What in the world does that mean? It means that training is both more complex, and I would argue the complexity makes it a little bit simpler. What in the world am I talking about? If you're not confused by now, I'm sorry. I don't know how to make it less confusing, but we're going to try. So here's the deal. When someone says you need to do high intensity interval training and you're going to get all these benefits, it's true to a degree, but you're going to miss out on all these other things that don't occur. When you say just go do zone 2, you're going to get all these benefits over here in this Venn diagram part, but not everything else over here. Same with sprint interval training, same with every intensity in between, because everything works to a degree, but nothing does everything. Okay, this is, again, simple. Nothing does everything. There's no magic paces. We know that. We now understand the science. If you want to go deeper, guess what? Recent review found 164 different exercise-regulated proteins in the mitochondria and 398 in the nucleus. What does that mean? A bunch of shit happens. And yeah, I'd love to simplify it and say this pathway leads to mitochondrial biogenesis, basically more quantity. This pathway leads to the quality, better respiration. This pathway leads to more capillaries. This pathway leads to XYZ. But it does not work like that. Instead, what we know is the same thing that we learned in studying the history of training. If you want to maximize or optimize aerobic development, you need a little bit of everything in the right dose. And the right dose is going to differ for every individual, but we have some general principles behind this. Now, one more step before I tell you, okay, what in the world does this mean for your training? Another way to think about this is a little simpler is this. We only train the muscle fibers that we recruit. Okay? So if all I'm doing is long, easy, slow stuff, guess what? Even if I go for a long duration, and there's some research dating back to the world-class runner Peter Snell found this, over time, as my slow twitch muscle fibers fatigue a little bit, I'll call in more hybrid fibers. Okay, more mixed fibers. And if I go a really freaking long time and I run out of glycogen, there's some research that shows, okay, I might dip into my fast twitch fibers a little bit. Some of the debate is whether I actually dip into recruiting them or they just say, screw it, send the fuel over to some slow twitch fibers by the lactate shuttle and we'll keep things going in that way. But for simplicity's sake, let's think, if you go a really freaking long time, eventually you'll recruit a little bit of fast twitch fibers or some intermediate mixed fibers, okay? So the problem is this, is if I never go for a really long time and I just keep repeating my hour run, hour bike, hour whatever, I recruit relatively the same fibers. So I'm training those slow twitch fibers really well aerobically. But if I want to train the intermediate fibers, the mixed fibers, or even the fast twitch fibers, I gotta go a little bit faster, right? So what do? You say, okay, I'm gonna include some high-end aerobic stuff, some lactate threshold stuff. Great. Now people are gonna say, oh, Steve did a video on the Norwegian doubles and the Norwegian singles, like lactate threshold. You recruit some fast twitch fibers, so it must give you the best bang for your buck. No. It's going to do a pretty good job, but you're still missing out because you're not training the high-end fast twitch fibers. You're not training or high-end intermediate fibers, the fast twitch fibers aerobically, and you're not getting some of those bang for our buck in terms of all those proteins that we talked about in that Venn diagram. Okay, so what do you have to do? You got to include some stuff that's a little bit faster than lactate threshold, sometimes much faster. Why? So we can train some of those intermediate fast twitch fibers or even the fast twitch fibers aerobically to increase their mitochondria, respiration, and quantity, and all the other things that go with it when we're looking at lactate shuttles and capillary density and all that junk that we can get lost in. The point is this: if we want to train well aerobically, we've got to do a bit of everything. So let's break it down. We went through a ton of science. So what? If the goal is to maximize aerobic development, what are we looking at? First off, we have to know the time constraints, which is, again, it varies based on the different aerobic adaptations, but generally aerobic adaptations take longer than some of the more high-intensity anaerobic speed endurance type adaptations. Why? Because often those adaptations are either more neural in terms of recruitment and efficiency of recruitment, which occurs generally on a faster timescale, or the response to metabolic stressors, where we build up some sort of buffering capacity or fatigue resistance, which again occurs on a faster timescale. Aerobic adaptations often rely on more structural changes, building up, creating more mitochondria, okay? Things like that. Increasing capillary density so that we can get some more blood flowing in and out, okay? All of these things that generally take a little bit longer. Some are a little bit faster. Sometimes capillarization can occur a little bit quicker, but in general take longer, okay? So what does that mean? It means we've got to start where Arthur Lydiard told us many years ago, and Pavio Nurmi told us years before that, although he did his with walking, which wasn't quite as efficient, but it still was the same idea, which is build a base of lots of volume. Why? Volume optimizes capillary density, okay? Much more so than high intensity stuff according to the research, and it provides a robust long-term stimulus for mitochondria, both quantity and a little bit of quality. Okay, quality, how well the thing works. Okay, and generally, endurance athletes have more slow twitch fibers, which means, again, the potent stimulus, give it what it wants. Lots of long and easy. Okay, once we get beyond that, the volume is the trigger, then we have to start looking at, okay, how do I start shifting the stimulus a little bit away from just volume to we need a little bit of metabolic stress and recruiting more fibers into the situation to stress things. This is where we come into our high-end aerobic, marathon pace, half marathon pace, lactate threshold, about the pace you could sustain for an hour or a little bit longer depending on what we're calling it here. The reason for this is pretty simple, is just below lactate threshold is where metabolic clearance rates are the highest. And this makes sense because what is lactate threshold? A kind of reflection of production and clearance or utilization of lactate itself. So when we look at metabolic clearance, that's when it's at its highest. So as with anything, the stress is pushing that system to adapt. So we adapt. So when we look at lactate threshold training or high-end aerobic, here's how I like to do it. First, you bring in some sort of marathon pace or steady sort of training to bridge the gap between easy and threshold, okay? Why? Again, you can go a little bit longer, use that volume trigger, or use some sort of progression at the end of a long run or progression in the middle of an easy run. That's one of the best ways I like to introduce this stuff. Provides a robust stimulus. And it's not as quite as taxing, both mentally and physically, as being right on the lactate threshold. Then what we want to do is we want to get towards this like sub-LT. So again, lactate threshold, lots of talk around it. If we say it occurs at about 3.5 millimoles of lactate, it's going to vary based on everyone. So don't use that as a, here's the law. But we want to be about a half millimole below that. 3, maybe 2.5 to 3. Little bit safe to begin with, so we aren't pressing that edge. And we want to do threshold work at that stuff, or sub-threshold work. You could do it any number of ways. You could do it in like the Ingebrigtsens and do some Ks or 1200s. You could do it the traditional Jack Daniels, may rest in peace style, where you're doing 20 minutes, 25 minutes, 30 minutes. You could do it in the way that I like to do it, which is just say, hey, here's a total time I want you to spend at this intensity. Let's say 30 minutes. Split it up however in the world you want. Okay, the point is to spend enough time at this relative intensity to kind of push those adaptations. Over time, okay, you either want to increase that volume a little bit, or you will naturally run a little bit faster at the same metabolic stress or the same kind of relative effort, okay? How you do the workouts doesn't matter to me. Get creative on it, okay? Once we've got that sub LT right below the line, then we look at, okay, we're going to press it. We're going to ride that line, okay? For some people, you might skip a little bit of the sub LT and press it. For middle distance runners especially, sub LT can take away, as I talked about in the Norwegian singles video I did. Check it out. Sub LT stuff can somewhat tip the seesaw of speed and endurance a little bit more, so I like to go straight into the lactate threshold work. And here essentially is you're just riding that line, right at that line or right below it, and trying to do that. Now, once we do our traditional threshold work, all of that is what I'd call pushing the threshold. You're going below it and you're saying, hey, I'm going to push this thing to the right side of the lactate curve to get a little bit faster. What's often missed is to develop aerobically maximally, to get the most bang for our buck, we then have to pull the threshold. Have to go a little bit beyond it. Introduce some lactate into the system. Go over the edge a little bit. Get over our metabolic clearance rate optimum function. Throw some junk into the bloodstream and muscle cells and all that stuff, and let ourselves deal with that. And most importantly, recruit a little bit more fast twitch fibers so we can handle it. What does that look like? At first, it might be some sort of combo workout where you say, I'm going to go 20 minutes right below threshold and then 5 minutes or a mile right above it. Okay? It could be some sort of alternations, which I love to do, where you're essentially, borrowing it from Canova. You're going 800 on, 800 steady, where the 800 on is maybe 15K pace or 10K pace, and the steady is maybe marathon pace. So what are you doing? You're injecting a little bit of junk into the system, slowing down so it's not easy, but you're still in a high-end aerobic state and forcing your body to clear or utilize that lactate and other stuff as fuel. It's a great way to train aerobically those fast twitch fibers. You can also do some Igloi style aerobic intervals, which I've done a video on. For a middle distance athlete, this is often something like doing a 150 with 50-meter jog, or a 200 with a 100-meter jog, or a 300 with a 100-meter jog, where you're doing not that fast, but faster, 10K, 8K, 5K pace, maybe even 3K pace. And the short rest allows you to stay aerobic, and lactate levels are going to go up a little bit higher than threshold, maybe up to 5, 6, 7, 8, depending on how you're manipulating the variables. But you're still primarily aerobically training, so you can get some of those adaptations, especially in fast twitch fibers. The last thing I'll say is in elite athletes, and Canova pointed this out, and I've seen it as well, is you can actually create a short-term maximum lactate steady state above lactate threshold. Okay? Wait, what? How does that work? What happens is elite athletes have such robust aerobic systems that sometimes even running close to 10K pace, their lactate might be steady at 5 to 6 and not going up much at all. Because the aerobic system, from their slow twitch fibers all the way up to their fast twitch fibers, is really freaking dialed in, okay? And no, they can't sustain that for an hour, but for a 15, 20-minute period within that 10K pace, they might be riding that line of not lactate, not going up much. How do you do that and develop it? You develop a really good lactate threshold and aerobic system, and then You do some of this pulling up stuff of alternation, of combos, of critical velocity type work where you're really saying, okay, I get it. We're over the lactate threshold. Our lactate's going to go up. But instead of it going up exponentially or drastically, we have a very small rise because we've trained aerobically, including our intermediate fibers and our fast twitch fibers, so well. So here's my masterclass in developing aerobically. Lots of easy to set the stage. Get into the sub-threshold marathon pace to half marathon or hour length distance. You want to utilize a bit of both, okay, because they attack things in slightly different ways, okay? The closer you get to lactate threshold, the more it's a little bit more of a bang for a buck, but it can be tricky to ride that line. And then when we top that off with more alternations, combo works, some critical velocity stuff to really boost things. And I got to say, as you're making this progression to develop aerobically, you're not leaving things behind. You're not going from, oh, forget the long runs, forget the easy stuff. Now we're just doing all lactate threshold. No, you've got to support things and maintain it along the way. If you do that well, you're going to be in a great place aerobically. The only word of advice or caution I'll give you is, again, back to the Norwegian singles, back to other videos that I've made, is remember training is like a seesaw, endurance, speed. If I go all the way on endurance without counterbalancing whatsoever, my speed and anaerobic capacity or how fast I could run a 400 and how much lactate I could produce is going to go down. So if you're doing a heavy threshold block of training, just counterbalance it with some good hill sprints, faster work, sprints on the track, or maybe some longer one-off hills, or any variation of the things that I've talked to in the developing speed videos I've done in the past. That's how you develop aerobically. So remember, you don't have to do all of it. Okay? Depends on your goals. Depends what you're trying to do. But if you want to optimize or maximize aerobic development, you gotta run the gamut. Because we need all those freaking proteins that we're still understanding, all those signaling pathways that we're still in understanding. We need at some point all of them to get developed so that we get a robust signal, which translates to functional adaptations, mitochondria increases, other things, which translate into increased aerobic performance. So there you go. Hope that helps. Hope you didn't get too lost in the weeds. Again, my book, Science of Running, breaks some of this down as well. It's a little in the weeds as well, but it helps to solidify this. And then I'll include some studies in there if you really want to go deep on the 2 latest reviews and research studies on some of this metabolic signaling pathways that has really expanded our view. So thanks everybody for watching. Until next time, take care. Thumbs up. Like, share, follow, all the things you're supposed to do on YouTube.